All right, so guys, in this video, we're going to talk about the mean value theorem, which if you watch the video on Rolle's theorem, you'll see that this is a much more general case, but one that's kind of similar as well. So what's happening is we've got our f that's still continuous on a closed interval and differentiable on the open, but those are the only two hypotheses in this theorem. If those two things are true, then there exists at least one c on the open AB such that f prime of c equals this thing. Now, again, don't let the notation get in your way. We talk about the slope being the derivative, right? So f prime, here's our slope at c, is going to be equal to, and if you pay real close attention to this is actually a slope as well. This is a rise over run, change of y over change of x between a and b. And so this slope essentially equals this slope right here. So let me show you what this looks like with a picture. So if we've got our A value here and our B value here, we're no longer required to be on the x-axis. So maybe we'll say this is our A value, and we'll maybe connect a dot, I don't know, something like this, where we've got a B value here. Then with this being f of A and this being f of B, the slope between A and B, which would be this guy right here, there should somewhere between A and B be a place on the curve where we would have an identical slope. And by identical, graphically, we're talking about parallel. So this guy here might give us x equals c. Okay, so again, let's talk through this. You can see that our function f here is both continuous on the closed interval and differentiable on the open. Therefore, there's got to exist at least one value between a and b, this guy, where the derivative at c, the slope right here at c, is equal to the slope between a and b. And graphically, we could tell that because they're parallel lines. And so again, this is a more general idea from Rolle's theorem, but needless to say, it's all about those slopes, it's all about those derivatives, and we'll go ahead and I'll pause the video here, I'll clear the screen, and we'll take a look at an example similar to how we did with Rolle's theorem. Okay, so again, we're going to verify the hypotheses and find all c. So for the hypotheses, remember there's only two of them here. The first one, we need to confirm that we are continuous on the closed interval 2 to 3. And the second one, we need to confirm that we are differentiable on the open interval 2 to 3. So in order to do this, a couple things that you might consider. The function f can be rewritten here as x squared plus 1 over x. Okay, so if I combine those into those two terms into one term, we can see that the only place of discontinuity would be at x equals 0, and that's not in our interval, so I know we're good there. So check. Differentiable on 2 to 3. Well, what you might do there is go ahead and take the derivative. Once you take this derivative, you would get x squared minus 1 over x squared. You could certainly work that out on your own. But once again, we're still differentiable on the open interval 2 to 3. So we're good there. Now, what we're trying to find is the c values now, such that f prime of c equals f of b minus f of a over b minus a. Well, our f prime of c, that's going to be our derivative right here, evaluated at c. So we would have c squared minus 1 over c squared set equal to now this slope formula right here. Our function evaluated at 3 minus our function evaluated at 2, right? That's our a, that's our b, divided by 3 minus 2. So our function evaluated at 3 minus our function evaluated at 2 divided by 3 minus 2. When all is said and done here on the right-hand side, that does simplify to 5/6. And from there we could solve and we would get c equals plus or minus the square root of 6. So again, plot this on Desmos, see what you're dealing with. You can even plot those lines in there if you need to, but I think this is a good example of what to look for these types of problems. I do want to finally point out as well, remember what I said in the past a couple times, all we care about is the interval 2 to 3. That negative root 6 does not fit in there, so our final answer would only be positive root 6 for C. So pay close attention to those. No one's looking necessarily to trick you on that, but you don't want to get something marked wrong on My Math Lab by simply including a minus when it's not actually in the interval. Okay, so again, hopefully Rolle's theorem and the mean value theorem went well for you. They're very interesting, intuitive theorems, ones that we can confirm pretty easily and find all values of pretty easily as well.